Welcome, everyone. Today we have a talk by Graham Priest, a professor of philosophy at the City University of New York Graduate Center. Graham is known for his work on paraconsistent and other non-classical logics, but today he's going to speak on the philosophy of set theory. Thank you, Graham, for accepting the invitation. Please.
Thank you. So first of all, thank you to Stanislav and Lev for inviting me. It's a great pleasure to be here to see some very old friends and some people I don't know so well. So thanks for coming. We find ourselves in very strange times, of course. I was in Moscow just under a year ago. And at that time, none of us had any conception of what we were heading for. But the world can change suddenly and will continue to change suddenly sometimes. So we have to adjust to the new times in which we find ourselves. Anyway, it's a pleasure to be with you guys who are only virtually and online and to share some ideas. So as Stanislav said, what I want to talk about is the universe of sets. This is not a technical talk, it's a philosophical talk, although it spins off some technical ideas, as you'll see. And it applies a certain idea to the cosmos, and that's perspectivalism. Now, just to give you an idea of what perspectivalism is, it's an idea you're very familiar with. So ask, for example, if a joke is funny. You can't say whether a joke is funny or not because it depends on your sense of humour. So the British find things funny which I've learnt the Americans don't, which the Americans have very different senses of humour. So things are not funny, jokes are not funny, or stories are not funny simpliciter. They're funny or not funny with respect to a perspective, the perspective of a sense of humour. Similarly, a dish, a food, okay? You can ask whether it's tasty. And some people like some things and other people find the same things pretty horrible. So whether a dish is tasty is not true or false simpliciter, it's true or false with respect to a perspective provided by a palate. So the notion of perspectivalism is familiar to you, but I want to apply it in an area which it hasn't been applied before, as far as I know, and that is mathematics, or an area of mathematics, because perspectivalism is a kind of relativism. Truth is relative to a perspective. So it seems to be unlikely that it could be applicable to a domain where there are objective facts, facts which are not true or false with respect to anything. And of course, normally we take mathematics to be such an area. However, I want to apply perspectivalism to it for a particular reason, which we will come to. So this is where we're going. Okay. So I hope you can all see my screen. I've just changed the slide, which is a sort of a table of contents of where we're going. You've just had the introduction, so that's the bit. That's the first bit. What area of mathematics do I want to apply perspectivalism to? Well, I want to apply it to set theory, and in particular to the question of whether there is one universe of sets or many. So that's really the first half of the talk. I want to talk about whether there's one universe or many. I want to apply perspectivalism to it, and then I want to sort of finish that section of the talk by making the pluriverse of sets even bigger. And we'll see how in a second. That's the first half of the talk. That will raise the question of mathematical pluralism, which is what the second half of the talk is about. And I'll apply the notion of mathematical pluralism to what I've just been saying. So that'll be the second half of the talk. Now, I don't know quite how long we have. I see nearly 15 minutes has gone already. So I don't think we're going to get through this all. That's fine too. If we get through the first half, that'll be enough. If we can get through some of the second half, that's good too. But we'll just see how the time goes. So let's start with the universe and the pluriverse. Is the universe one or is it many? Well, look, there's a standard view in set theory, which of course you're familiar with, that there is essentially one universe of sets. It's characterized by the axioms of the Milo-Frankel set theory, with choice, ZFC. I'll take that for granted. There's one universe of all sets. It's characterized by those axioms. Of course, those axioms don't settle all the issues. There are a number of famous problems which are independent of those axioms. The most famous one, I guess, is the continuum hypothesis. Even though that issue is not settled by the axioms of ZSC, because there is one unique universe of sets, the continuum hypothesis is either true or false in it. It's just that we don't know which. Okay, so that's a familiar view, and I think it's probably fair to say that that's the kind of orthodox view, at least a very standard view, maybe at least till recently. Because what we've seen, I guess, over the last 10 or 15 years is a slightly different view. And it's been pushed largely, I think, by this man. This is Joel Hempkins. He was a colleague of mine at New York, but he's been poached by Oxford, so he now lives in Oxford. Anyway, in this photo, he's got a kind of sideways perspective of something that looks like a bit of New York. Anyway, so what Joel suggests is the view that there is a unique universe of sets is in fact wrong. So this is Joel explaining his view. There are diverse, distinct concepts of set, each instantiated in a corresponding set theoretic universe, which exhibit diverse set theoretic truths. Each such universe exists independently in the same Platonic sense that proponents of the universe regard their universe to exist. I don't think it's quite right to say that they're that they're different conceptions. I mean, they're all the Milo-Frankel ZFC sets. It's just that there are a lot of different universes. Of course, the axioms of ZFC are true in all of them, but the continuum hypothesis, say, is going to be true in some of those universes. It's going to be false in others. So there's no question of whether or not the CH is true or false. It's going to be true with respect to some universes, false with respect to others. So Joel calls this the multiverse. I kind of prefer pluriverse. If we get round to it, the pluriverse is going to get an awful lot bigger today, as you'll see. Anyway, what drives the pluriverse view is, first of all, the fact that there are so many questions in set theory that are apparently irresoluble, at least if you might take consensus to be a mark of solution. I mean, for example, we've been trying to figure out the truth of the continuum hypothesis one way or another for a long time now, and there's just no consensus on the matter, I think. So that already weakens your feeling that there must be a determinate truth. That, of course, doesn't disprove it. But there's another thing which drives Joel's picture, which is when people work in set theory, a lot of what they do nowadays is construct models. So there are various techniques of set theoretic construction, universe construction, like forcing and so on. Set theorists nowadays have a pretty good sense of how you can use such techniques to construct models with various properties. For many of the things which are independent of ZFC, we know very well how to construct a model of ZFC in which it holds and which it fails. Now, a model is not exactly a universe, but for present purposes, they're not that different. And I rather suspect that Joel identifies models with universes. And if you take this picture, then of course, since there are many different models of set theory, there are many different universes. So there isn't one single universe of sets. There is a pluriverse of these damn things. I might add that I'm not going to defend the pluriverse view. I think it's very plausible, but that's the sort of argument that Joel gives when he defends the pluriverse view. So you might depict the pluriverse view as something like this. So we've got all these universes, and I've only drawn 4 of them. There are a few more. And they all are independently real, whatever reality comes to. Joel's a Platonist, but you don't have to be a Platonist. They're all real in whatever sense of reality you think applies here. Now, as looking at this diagram for a moment will suggest, there's an obvious problem with the pluriverse view, because it damn well appears as though all these universes in the pluriverse reside within one big hyper-universe. That is the totality of all universes and all their doings. They live in one big universe. Indeed, when you start to think about what set theorists are doing when they construct models of various set theoretic principles, they're constructing certain models. What are they constructing them in? Well, the obvious answer is they're constructing models within the universe of sets. So the pluriverse view seems to be kind of self-refuting, because even to explain it, you need to seem to presuppose that there is a unique universe in which all the members of the pluriverse find themselves. I think it's fair to say that people who don't like Joel's view find this the most obvious objection, and it's why it doesn't persuade them. Okay, so that's the pluriverse, and that's the obvious problem for it. What I want to do now is to suggest a solution to it. I don't know whether Joel subscribes to this solution. He's never said exactly this in print, but he gave me the idea, in fact, because we were having a discussion in Germany a couple of years ago, and I was talking to him about this problem, and he said something to me which sounded very much like pluralism, perspectivism. So I thought, well, that's an interesting idea. Let's pick it up and run with it and see where it goes. So I'm going to see where it runs. So back to perspectivism. Now, I explained briefly what perspectivism is. Let's have a slightly closer look at it. So perspectivism is the view that certain claims are not true or false simpliciter. So the example I used earlier is this: such and such joke is funny. That claim is not true or false simpliciter. Okay. What is true or false simpliciter is that such and such a joke is funny with respect to a sense of humor. Okay. So perspectivism means that the truths about the subject in question are relative to a perspective, a sense of humor, whatever you want to call it. I'll call it a perspective. Okay, now perspectivism is actually a very well-known view in philosophy. I don't know that it's well-known to philosophers of mathematics, but it's certainly very familiar to many philosophers. And it's important to distinguish between local and global perspectivism. Local perspectivism is completely unproblematic, I think. It's when you apply perspectivism to a particular topic, such as humor, taste, or spatial position. Obviously, that's perspectival as well. So local perspectivism is a view where you apply perspectivism to one particular well-defined topic. Okay, global perspectivism is when you apply it to everything. Okay, so it's not just that truths about humor or taste are relative to a perspective. Everything, every truth of any kind is relative to a perspective. This is a strange view, and you might want to say, well, who holds that? And well, here are a couple of people. So Nietzsche is often accused of being a perspectivalist. Many people subscribe to this interpretation of Nietzsche. Truth for Nietzsche is always with respect to the perspective you've taken it. Actually, interpreting Nietzsche is a difficult thing. You always know what Nietzsche is against, okay, because he's an iconoclast. It's often not clear what he's for. So I'm not sure this is the right interpretation of Nietzsche, but a lot of people hold it to be. But one group of philosophers who are absolutely surely global perspectivalists are the Jain philosophers. So the Jainism is an Indian philosophy. It's coeval with Buddhism, starts about the 5th or 6th century BCE. And the Jains have a nice metaphor. They say, look, when you look at reality, you've got to think of it like a cut diamond. So a cut diamond has many faces or many facades. And when you look at reality, you're only ever seeing one perspective. And something can be true in one perspective, one facade, and false in another facade. So they quite consciously have a global perspectivalist view of the nature of reality. Any truth claim you make is going to be relative to one facet, one facade, one perspective of the reality, which is, well, of reality. So that's the distinction between local and global perspectivalism. I'm going to apply perspectivalism to set theory, and so a question that now arises is whether this is a form of global perspectivalism or local perspectivalism. Now, why is that important? Well, ask yourself, when you have a perspective, what are the perspectives of? Okay. Now, if you are a local perspectivalist, it's easy to answer that question. The perspective of whether a joke is funny or not, what's that a perspective of? Well, it's a perspective of the story told or the story read or whatever. Whether or not the dish is tasty is relative to, well, it's a perspective of a certain cooking dish. So this is easy. If you're a global perspectivalist, things are harder. So take the Jain view, for example, and they ran into trouble because of this. I said that reality for them is like a cut diamond. And you have each facet, each facade, and any claim you make is a claim about one of those facades. So what is it that these things are facades of? Now, okay, think about it for a second. Anything you say is true only with respect to some facade. You cannot say anything about the thing which the facades are facades of, because anything you say is true with respect to some facet and some facet only. So in other words, it's kind of hard to say what the perspectives are perspectives of if you're a global perspectivalist. And this is a problem because it sort of makes the thing which has the perspectives a kind of indescribable Ding and sich. Well, that's not great. Okay, I'm not saying it's impossible, but it's certainly an uncomfortable position to be in. Okay, so that's a little bit of thinking about perspectivism in general. And what I want to do next is apply perspectivism to, okay, you've guessed it, the pluriverse of sets. So we might draw the following diagram. Again, there are 4 members of the pluriverse, V1 through V4. And there's this sort of funny thing in the middle, which is a fractal V. And the dotted arrows indicate that each of the V's gives a perspective on fractal V. So each of the members of the pluriverse has a totality of all sets. Okay, in ZFC it's a proper class, but it's clearly a totality in some sense. So each of those has its own universe of sets, as it were, and each of those provides a perspective on this fractal V. So notice the most important thing is that there's no hyperuniverse of sets. So this is an objection, this is a reply, if it works, to the view that the members of the pluriverse must live within a hyperuniverse. They don't. There is no hyperuniverse, there are just the universes, but each of the universes provides a perspective on, well, okay, fractal V. Okay, this is the thing of which they provide perspectives, and the obvious question is, what the hell is fractal V? Okay, well, this is not global perspectivism, because we're not talking about truth about everything, we're talking about truth about the universe of sets. So we're not in that problem. However, it's not quite as straightforward as the case with humour or taste. In those cases, there's an obvious answer to what the perspectives are perspectives of. I don't think there's such an obvious answer in this case, but I think the most natural answer is this. What fractal V is the mathematical object, which is the totality of all collections. Now notice that although it's a totality, it's going to have no intrinsic structure. If it had an intrinsic structure, you'd be back with the problem you had originally of supposing there is an intrinsic totality, or there's a totality of sets with an intrinsic structure. That's the move that's got to be finessed. So you can take the perspectives to be perspectives of V. V is the totality of all collections, but it has no determinate structure as such. Each of the members of the pluriverse has a perspective on the structure of fractal V. And each of the perspectives afforded by each of the members of the pluriverse is equally good, because there's no objective, i.e. perspective neutral, fact of the matter.
I ask you a question at this point.
Please do.
So when you say that there is no structure on this mysterious object V, what do you mean by this? Are different universes of sets somehow related to each other in some way or not? So.
Yeah, look, that's a good question, Lev. I want to come back to that in a moment. So can I put that question on ice for a minute, and I'll promise we'll come back to it, and you can push me harder when we get there, okay?
Okay.
For the moment, just run with the thought that in some sense, all the universes provide a perspective on the totality of sets, although it itself has no determinate structure. The structure is only ever a matter of perspective. Okay. So that's perspectivism, and that is the putative solution to the most obvious objection to the universe. Now, actually, this does start to address Lev's question, maybe not completely, but this. If you take the pluriverse, the plurality of sets, some claims are going to be absolute in the sense that they're going to hold in all members of the pluriverse. So all members of the pluriverse model ZFC, so the theorems of ZFC are going to be absolute in this sense. But some claims are not absolute. So obviously, things like the continuum hypothesis are going to hold in some members of the pluriverse and not. So the continuum hypothesis is not absolute. Now, it's kind of more complicated than that, because you might find yourself in this situation. So you can have a pluriverse within, you can have a member of the pluriverse within a larger member of the pluriverse. So here, V1 is a pluriverse which exists within the member of the pluriverse V2. So you can think of it as a model within a model, if that helps. So V1 and V2 will each have a take on what fractal V is like. Both of them will think that it's uncountable. That's fine. V1 will, of course, take itself to be uncountable. But from the perspective of V2, V1 may very well be countable. Indeed, if you look at Joel's writings about the pluriverse, one of the axioms of the pluriverse that he likes is that every member of the pluriverse is countable with respect to some larger pluriverse. How plausible that is, I'm not sure. But certainly, standard forcing constructions are going to show us that there can be models within models, and even though the model takes itself to be uncountable, a larger model will take it to be countable just because in the larger model there are more functions and so on. Notice also one further thing. If you're sitting in V2, you can see V1, but you're going to think that V1's perspective is very partial. That's okay. It's just that if you're in some members of the pluriverse, other members of the pluriverse are going to have what appears to be a partial perspective. In fact, if you look at Joel's view, every universe will have a perspective which seems partial with respect to some larger member of the pluriverse. So that's a start of addressing your concern. I don't think it gets to the heart of it yet. Do you want to say anything further at this point? Because there's more to the story.
So I had a question about what's going on. So you mentioned that the pluriverse should have no structure, but then you mentioned that Joel considers this essentially first order axioms about pluriverse, and so you do allow this first order reasoning inside pluriverse or not?
I'm sorry, I can't see who's speaking.
So it was me, but I don't know. So maybe you just to scroll among the speakers.
Okay, Fedor. Okay.
Yeah.
Okay, Fedor, can you ask your question again, please? Because I'm not sure.
Yeah, sure. So you mentioned that pluriverse should have no structure, but then you mentioned that Joel considered axioms about pluriverse. So this axiom that every universe should be countable inside other universe. So do you allow this first order reasoning inside a pluriverse?
Oh yes, there can be relations between members of the pluriverse. This is starting to get at the worry that Lev, I think, was articulating. you might worry about what structure that structure is being tracked in, okay? So there's a worry here that you're going to be back with a non-perspectival view. I think that's a serious worry. But I want to come back to that later in another part of the talk, okay? But setting that problem aside for a moment, the crucial thought here, as far as the story goes so far, is that there is a multitude of universes. There's a plurality of these. Each of those gives you a perspective on what the totality of sets is like, although all perspectives are equally good. Although from some of the members of the perspective, other members, so for some of the members of the universe, some of the other perspectives may appear partial and so on, but that's okay. All right. So that is a reply to the main problem faced by the pluriverse, as far as I understand it. And you might want to say, well, where does that take us? Now, I'm not going to try to defend the pluriverse. I'm not even going to try to defend pluralism, although, of course, objections to it interest me greatly. What I want to do is pick up the idea and see whether one can run with it, and if so, what comes of it. So what follows is not a defense of the pluriverse or of perspectivalism. I just want to see what we can do, because once it's on the table, there are some very obvious moves that can get made. And here's the first one. Okay, this is Joel himself. The background idea of the multiverse, of course, is there should be a large collection of universes, each a model of some kind of set theory. There seems to be no reason to restrict inclusion only to ZFC models, as we can include models of weaker theories, ZF, KP minus, KP, and so on, perhaps even down to second order number theory, as this is set theoretic in a sense. At the same time, there's no reason to consider all the universes in the multiverse equally, and we may simply be more interested in the parts of the multiverse consisting of the universes satisfying very strong theories, such as ZF plus some large cardinals. Okay, so we shouldn't fetishize ZFC. And I want to take that seriously, because here is a way not to fetishize ZFC. I'm going to change the logic. I'm going to move to a paraconsistent logic. The paraconsistent logic is LP. I'm not going to spend a lot of time any time at all, describing what LP is. For some of you, it'll be very familiar. Some of you, it won't be. But the salient fact about LP in the present context, well, the salient facts are, first of all, it's a paraconsistent logic. So you can handle theories which are inconsistent without them implying everything. They don't collapse into triviality. The second facet of LP, which is important in this case, is that LP is a generalization of classical logic, in the sense that any classical interpretation is also an LP interpretation. There are going to be interpretations which are non-classical, because one way of looking at LP is that you've got a third truth value. You can think of it as something like both true and false. But if you look at the details of LP, what you'll see is that two of the three LP values, true only and false only, work exactly the same as they do in classical logic. So if you restrict yourself to models in which formulas have only those true truth values, you've got exactly classical logic and classical models, but you're going to have more. So what we've seen then is that every classical ZFC model is an LP model. So the class of all LP models, or LP universe, if you like, contains all the ZFC models, and so, in a sense, it expands the universe. In fact, it expands the universe in a quite interesting way, because what you can show, and I'm not going to go over the proofs now, if anyone wants to know, I can give you references. There are non-trivial LP models, which are models of all the theorems of ZFC, plus this thing here, the naive comprehension principle. Now, of course, that's not a theorem of ZFC. If it were, ZFC would be trivial. However, there are LP models, which are models of all the theorems of ZFC, plus naive comprehension. If you've never met this before, you might be slightly puzzled as to how this is possible. Why don't these LP models collapse into triviality in a way that naive comprehension would collapse into triviality in classical logic? And the answer is that here's a material biconditional. It corresponds to a material conditional, and in LP, this does not detach. So you cannot apply modus ponens for the material condition. That's why these models do not collapse into triviality. They model all the instances of naive comprehension, and let me emphasize again, every theorem of ZFC. So what we've seen is that if you move to LP, you've expanded the models of set theory, and you've expanded them in a very interesting way, because you've got all the ones you had before, all the classical models, plus some others, including others which model the naive comprehension principle. So the pluriverse has got bigger, okay, kind of interestingly bigger, because the inconsistent models, like the ones which model naive comprehension, provide a whole and very different perspective on what the totality of sets is like. Okay, so moving to LP expands the pluriverse. Now, of course, you might object to this. If you're a dyed-in-the-wool classical logician, I guess there are still some of those around, what you're going to say is, yeah, okay, but these don't provide legitimate perspectives, because paraconsistent logic is just a crazy logic. That's a view. I'm not going to try to answer that now. I'm going to finesse it, because actually this is the end of the first part of the talk. And what I want to do is talk about mathematical pluralism in general, which involves paraconsistent logics as one sort of prime part, but by no means the only part. All right, so that's the end of the first part of the talk. What do we do now? Should we pause for more questions? I'm aware that Lev's question is still on the table. Do people want to ask other questions at this point, or shall we press on? Lev, Stanislav, what do we do?
I think we should continue, and all the questions will be at the very end of the talk.
All right. Okay. So let's move on to the second part of the talk, which is about mathematical pluralism. Mathematics, which is, in this case, a plural noun. So, look, a very standard view is mathematical monism, in the sense that there's only one kind of mathematics. It's a mathematics which uses classical logic, that is, the logic which was invented by Russell and Frege, maybe 130 ago, depends where you date the origin. And classical logic did a pretty good job of regimenting the mathematics of its day. And you might well hold that there isn't any other kind of mathematics. That all the mathematics we have is a mathematics which is based on classical logic. It's a view. Notice that this does not challenge the pluriverse view. The fact that we've got mathematical monism does not mean that you've only got one universe of sets. What it means is something like this. You have to reconceptualize set theory. So no one would balk at the following thought. There's no such thing, there's no unique ring, there's no unique field, there's no unique group. These algebraic structures were never meant to be categorical. Rather, each ring or each group or whatever is a realization of ring theoretic structure. And you've got to think of the pluriverse in the same way. There's no unique totality of sets. Rather, there are different ways in which this can be realized, and each is realized by one of the members of the pluriverse. So remember, the pluriverse is like a particular ring or a particular group or whatever. Okay. So there's no problem for the pluriverse and classical logic. Even if you move to a paraconsistent logic like LP, you can still be a mathematical monist, because you might hold that there is one correct logic for mathematics. Okay, it's not classical logic, it's a paraconsistent logic like LP. Now, that doesn't mean you can't be interested in classical structures. The classical structures are particular cases of LP structures. So this is not to say classical mathematics is wrong, it's just to say, well, there's more to it than classical mathematics. So nothing I've said so far challenges mathematical monism. However, there is a view which is now gaining ground, and I must confess that I share it, that mathematical monism is wrong, and what we face is mathematical pluralism. And mathematical pluralism is the view that there are many different kinds of mathematics. In particular, there are the kinds of mathematics which are built on non-classical logics, such as intuitionism, such as a paraconsistent logic. And we now know a lot about what these mathematical structures are like. They're perhaps not very familiar to mathematicians working in maths departments yet, but a good deal is known about these things. So let me just give you a few examples. There's paraconsistent set theory. I've just mentioned that. Another example is paraconsistent topology, which is kind of interesting because in paraconsistent topologies, you can deal with things like boundaries, which are inconsistent objects. So the boundary between a set and its complement can actually be a contradictory object which both separates a set and its complement, but joins the two together. So paraconsistent topology is kind of interesting. There's intuitionistic smooth infinitesimal analysis, which is a theory of infinitesimals. It's sometimes called nilpotent infinitesimal analysis. That has a structure which is now well understood. That spins off results in category theory, in particular topos theory. Heyting arithmetic plus Church's thesis is a perfectly good intuitionistic theory of arithmetic. But what all these theories have in common is that if you try to do these things in classical logic, all hell breaks loose. In particular, the theory becomes trivial. But the fact that you're using a non-classical logic preserves the non-triviality, and in the case of the intuitionist examples, preserves the consistency of these structures. Now, you only have to look and think about these structures, investigate them a bit, to see that these are structures with obvious mathematical interest. Of course, these are not classical structures, but they have mathematical interest. And why should a mathematician be interested only in some kinds of structures, namely the structures which are based on classical logic. As far as I can see, there's no good reason. Again, I don't intend to defend mathematical pluralism here, but I think it's about right. There are different kinds of mathematics, and in particular, there are branches of mathematics which are not based on classical logic. Now, let me just note two other things about mathematical pluralism before we move on. This is not the claim that all such mathematical structures are equally rich, interesting, etc. That's a different point. Even within classical mathematics, some structures are richer and more interesting than others, and that goes across the board. So this is not the claim that all such structures are equally good in every sense of good, simply that they're all equally legitimate parts of mathematical, or equally legitimate mathematical structures. Secondly, I note that we are talking about pure mathematics here. I'm not talking about applied mathematics. So applied mathematics is when you take a pure mathematical structure and you apply it to something else like physics, economics, biology, linguistics. When you apply a branch of pure mathematics in that way, then of course you want the right bit of pure mathematics to do the job. What that means we could argue about, but essentially it means something like you want the pure mathematics structure where the mathematical structure tracks the structure of the applied domain. And of course, if you do that, then not all bits of pure mathematics are equally good, because you want the right bit of pure mathematics. So mathematical pluralism applies to pure mathematics, not to applied mathematics. I say again, mathematical pluralism is just the view that all mathematical structures, whether they're based on classical or non-classical logic, are equally valid bits of pure mathematics. Okay, so assuming that, then let's come back to the pluriverse, because I've already expanded the pluriverse once. By moving from classical logic to LP, what we've seen is the pluriverse expanded. Now, if you're a mathematical pluralist, expanding it to just a power-consistent logic will seem just very limited, because you can do it with any other logic you like. And in particular, there are going to be members of the pluriverse which have rather different underlying logics. Let me give you some examples. Okay, so there's a set theory which has the axioms of ZFC, but is based on intuitionistic logic. There's a set theory which is based on the notion of spread. So again, this is using the intuitionist notion of spread. So the axioms are going to be a bit different because spreads behave a bit differently from ZFC sets, but you're using intuitionistic logic. There's fuzzy set theory based on Łukasiewicz continuum-related logic. There is set theory based on relevant logic, which we know quite a lot about. There's set theory based on quantum logic. Now, as Joel said, a mathematician may well not be interested in all these universes. I don't think any mathematician is interested in every bit of mathematics. But as pure mathematical set theoretic structures, given mathematical pluralism, they're all equally legitimate. So let's have all those in the pluriverse. What I've just done is make the pluriverse even bigger than it was before. So the real pluriverse then is going to contain a lot of these guys, okay? And a lot of them are going to be non-classical. All right, now let's come back to the structure of the pluriverse. And I think this is where I'm going to pick up Lev's question. So let us suppose that you have just expanded the pluriverse in this sort of gobsmacking way. You've made it so much bigger. You've got this enormous pluriverse. Now, each member of the pluriverse, you, is going to have its own logic, LU. Okay, that's fine. Let me write U forces A to mean that the formula A holds in the universe U. And sigma U is going to be the set of things which hold in U. And of course, that's going to be closed under LU, because that's the logic of the universe. Set theorists, of course, may well investigate each sigma U. We want to know what holds in each member of the universe. But, of course, set theorists will want to do more than that. They will want to investigate the properties of the universe themselves and the relations that hold between different universes. Give a mathematician a bunch of structures, and the first thing I'll do is ask about the relations between them. Okay. And the question is, when you do this investigation of the properties and relations, what set theoretic structure are you doing that in? Okay, I take that to be Lev's question. All right, now let's think about an answer. In fact, Joel has himself hinted at an answer to this question. So this is Joel again. This quote actually comes from a book that hasn't been published yet. It's from Joel's book on set theory in the pluriverse, which I think is due out later this year. So this is something that Joel told me is in the book. The multiverse perspective ultimately provides what I view as an enlargement of the theory-meta-theory distinction. There are not merely two sides of the distinction, the object theory and the meta-theory, but rather there is a vast hierarchy of meta-theories. Every set theoretic context, after all, provides in effect a meta-theoretic background for the models and theories that exist in the context. A model theory for the models and theories one finds there. Every model of set theory provides an interpretation of second-order logic, for example, using the sets and predicates existing there. Yet a given model of set theory, M, may itself be a model inside a larger model of set theory, N. And so what was previously the absolute set theoretic background for people living inside M becomes just one of the possible models of set theory from the perspective of the larger model, N. Each meta-theoretic context becomes just another model at the higher level. In this way, we have a theory, meta-theory, meta-meta-theory, and so on, a vast hierarchy of possible set theoretic backgrounds. And Joel doesn't say, but given his view, he's got to hold that they're all equally good in some sense. Maybe one might be a bit better because it's larger, but certainly if you're a perspectivist, each one is going to give you an appropriate perspective on the matters you're investigating. So let's run with that idea. Any universe which contains the universe in question may be used to study. So we've got a bunch of these universes, and we want to study their properties and relations. And any universe which contains them is going to provide the wherewithal to study them and their properties. So the answer is, you can do it any way you damn well like. Now, notice that a sub-universe may have a different internal logic to the super-universe. So I've already noted that you can have a classical model inside a universe whose logic is paraconsistent. So the classical model or the classical universe is going to have a stronger logic than the universe in general. And it can go the other way around. Because you can take an intuitionist model, for example, so a Kripke model, which is internal logic is intuitionistic logic, but that can exist in a classical universe. We know how to do Kripke models in terms of classical logic. So it's not required that the universes that you're studying and the universes in which you're studying them have the same logic. They can be quite different. Moreover, if you are in this situation where you've got a bunch of universes and then a sort of super universe to study them, different super universes may attribute different properties and relations to sub-universes. Okay. If you're working in a super universe with intuitionistic logic, you're not going to be able to establish all the same things about these universes as if you're working in a super universe with classical logic. Indeed, even the relation that U forces A may have different properties given the meta theory. For example, we know that Kripke models for first order intuitionistic logic are complete if you use classical meta theory, and they're incomplete if you use intuitionistic meta theory. So this relativity is going to hit quite hard. It may well be the case that a lot of the structure that you want to attribute to the universes and the relationships between them is going to be a hostage to the context in which you're working, that is, the perspective that you have. However, this is the important thing. Each of these super universes provides a perspective which is equally legitimate. So finally, the answer to Lev's question is what universe are you working in when you do the comparative stuff? Anyone you damn well like, and anyone is equally good. These are all equally good bits of pure mathematics. All right. One of the main proponents of mathematical pluralism is Stuart Shapiro. He has a very nice book called Varieties of Logic. And he spends a chapter worrying about this problem, which is obviously a problem which is going to concern any mathematical pluralist. And he comes to much the same answer that I've just given, as far as I understand it. He says this: to put the matter in general terms, if we become interested in relations amongst particular theories or systems S1 through Sn, then we need a perspective, theory, structure from which we can refer to S1 through Sn at once, so to speak, and we need some account of the relations between theories of systems S1 through Sn. But we don't need a single foundational theory that accommodates every possible mathematical theory or every possible logic. Indeed not. Any universe in which all the S1 through Sn live is equally good and will provide an answer to the question of the relationship between those things. Okay, so there is one more section, but it's to do with the threat of relativism, and it really is a sort of an added extra. So I'll do that if you want, but maybe this is a good time to stop and let people ask questions.
Then maybe I have a small question. Well, one of the problems I have with this multiverse perspective, which I think goes back to Paul Klein, is that no one has ever seen a universe, right? So the way we construct these universes is that we say, well, let M be an arbitrary model of ZFC, an arbitrary model. We haven't seen any model yet. And then we use that model in order to construct some Boolean valued model of ZFC plus something. In this way, we add some more structure to it. We still end up with a kind of arbitrary model. But now it satisfies the continuum hypothesis, or maybe the negation of the continuum hypothesis. But it's still like a kind of theory we constructed, rather than a concrete model in which every sentence is true or false. So that's roughly the problem I have with this view, is that it seems more natural to deal with different theories, which are necessarily incomplete, rather than talking about models.
Yeah, look, You say we've never seen one of these things. I mean, obviously you're not talking about vision here. But in whatever sense we haven't seen the members of Pluralverse, we haven't seen the universe either. I mean, what we have is ZFC, and then we strengthen it with different large cardinal axioms, if you like. It's not such a stretch of the imagination to think of each theory as defining a model, or more likely a bunch of models. And this is, I take it, what Joel is suggesting. I mean, the perspectivism has nothing to do with this, right? It's simply to do with whether the pluriverse is committed ipso facto to a unique universe. But if you think that all you're doing is investigating theories of certain kinds, I think Joel would be quite happy with that. I mean, he's just putting a model theoretic spin on your theoretical pluralism, as it were.
Thank you. Andrei Rodin?
Yeah, yes, thank you, Greg. I have actually two questions. My first question, probably similar to Stanislav's. One thing I can't quite understand is how theories are related to models, right? Normally, and what exact, relationship between universes and models, because sometimes you use kind of interchangeably. And thing is that normally one theory may have many models, right? And one and the same, say, object, some in the same structure can be model of many different theories, of course, right? All weaker theories would model, the same object would be model of. So we have this kind of duality between theories and their models. And so how this picture enters this picture of universe? That's first question, maybe.
Okay, can I take them one at a time? Otherwise I'll get confused. All right?
Yes, sure.
Let me answer that, and then you can give me the second
sure.
barrel, okay? Two parts to the answer. The first is that for present purposes, you can identify a model with a member of the pluriverse. I think that's what Joel does. And you might carp about that a bit, but I think that's fine for present purposes.
Oh.
Now, the more interesting part of your question is, what is the relationship between theories and these models? And of course, that's the subject that you investigate in model theory. This takes us back, I guess, to where we ended up in the talk, because that model theory is going to have to be done in some theory. Usually we assume it's classical logic. But if you do your model theory in intuitionistic logic, you're going to get some different results. So the question that you ask about the relationship between theories and models, the answer to that is going to depend on the universe of sets, as it were, in which you're working, and in particular its underlying logic.
Okay. If I may have also a question on your second part concerning mathematical pluralism. And here, actually, I'm not quite convinced about the idea that, say, changing logic, as you say, you get new mathematical structure. I don't think we ever see it in really in mathematics, right? I think the relationship between logic and something extra logical is somehow more involved. So it does work like we use some different logical theory and get new mathematical structure. So I simply think there is no such such example, and that's why I'm not really convinced. So I am convinced about this picture of what you call pluriverse, right? It's kind of say, I don't assume there is one right logic or one right universe or anything, but the very ideas which you didn't discuss just took for granted, right? That just having different logic, we get new structures. I think that's simply doesn't happen.
Okay, look, I'm not quite sure what to say about this, because it seems to me obvious that you do. I mean, I don't know if you've ever studied, say, relevant set theory or paraconsistent topology or the theory of smooth infinitesimals. I mean, these are mathematical theories or structures, if you like, which are based on logic, which is non-classical. Now, I agree that most mathematicians don't know much about these, but some mathematicians do. And if you think there's no such thing, I guess all I can say is go have a look at these structures and see what you think of them. I mean, to me, they have clear mathematical interest. And I don't see any principled way in which you can say these are not real mathematics.
Oh, just a small remark. I think that there are some interesting structures which are not based on classical logic, of course, but to my experience, the point is that they're almost always investigated within the framework of classical logic. So the meta logic is almost always classical. Well, I mean, of course, there are some important exceptions, but for the most part, people are doing non-classical logic within the classical meta theory.
Yeah, look, I think that's true as a sociological fact. But as you note, this is not universally true. I mean, for example, in Michael Dunk's book on intuitionism, there's a large chunk which does the meta theory of intuitionistic logic in intuitionistic meta logic. We know these, okay? So we know that these things are possible. Now, I agree with you that there hasn't been the same kind of thoroughgoing investigation of paraconsistent logics in a paraconsistent meta theory. But that's partly because most mathematicians aren't familiar with this stuff. I think we're going to see this change. Mathematicians are interested in structure, like pure mathematicians. And I think once you start to show mathematicians interesting mathematical structures, they're going to say, well, how can we get our head around these? And a non-classical meta theory is such a thing. So think of that as a prediction, if you like. But, you know, I don't agree with what you say is a sociological observation, for sure.
Daniil Kожemяченко.
Thank you. Graham, regarding this non-classical meta theory, is it possible somewhere to find, I don't know, maybe like a set theory or maybe some field in mathematics where no classical meta theory is possible? I mean, the examples by Stanislav and as far as I understand, even the ones that you propose were thus that you can try and give a classical meta theory to something like to this non-classical topology and so on and so on. But and in this case, I cannot see like a strict pluralism. But is it possible to have a strict pluralism in the sense that we have some structure which cannot be described in classical terms like at all?
Well, look, no, of course not, because you can do your meta theory in classical logic, but you can do it in intuitionistic logic. And at least to a limited extent with intuitionism, we know what that's like, okay? So of course you can study intuitionistic logic in a classical meta theory. You know, most classical logicians do that. Intuitionists are not going to be satisfied with that, of course. And so they want their meta theory done in intuitionistic logic. So you can do it both ways, and you're going to get different results if you do it both ways. Is there a right way of doing it? Well, not if you're a perspectivalist. If you're an intuitionist, yeah. Just like if you're a classical logician, yeah. But, you know, you can do it always.
Thanks.
Pavel Alexeyev.
First of all, thank you for your lecture and your interesting ideas. And I have such question of pure philosophical type. When we speak that there is no any kind, in any broad sense, of meta-universe or of one universe, and when we say that there's many different universes which does not correspond with each other, isn't this, in a pure philosophical sense, a purely metaphysical position?
Yes.
It is.
Yes.
Thank you.
That was easy.
The shortest discussion in philosophy I ever heard.
And I have another small question after this one. Isn't this metaphysical point of view any problem in developing of this system? For example, when we speak about metaphysics, for example, when we speak about metaphysical ideas, isn't it a problem when we try to develop them and make them more strictly formalizable?
Look, how can you do the philosophy of mathematics without taking on metaphysics? And even if you're a sort of dyed-in-the-wall universe Platonist, of course you're doing metaphysics. That doesn't necessarily mean that you're going to be worried about metaphysical issues when you do the mathematics. You can just do the bloody mathematics. But if you're trying to understand what is going on, you're in the heart of the philosophy of mathematics. And of course you're going to have to be worried about metaphysical issues.
As an example of any way of thinking about mathematics, without metaphysics, we can say about some philosophical views. For example, when we speak about mathematics as pure nominal, in a pure nominal sense. For example, that it's just language games.
Nominalism is a metaphysical view. As I say, look, you can do the logic, you can do the number crunching. You don't have to worry about the metaphysics. Of course you can. But as soon as you start to worry about what you're doing, whether it's Platonist, nominalist, whatever, you're doing philosophy of mathematics.
Thank you.
Sergey Nikolaevich?
Thank you for the great talk. I liked the Joel's work. I talked to him, and the step from the mono-universe in set theory view to multiverse view in set theory it's a huge step forward. I was really just annoyed that the classical or traditional set theorists are just bunkered themselves into this mono-universe point of view and try to find the very absolute truth about, at least trying to convince themselves that this very absolute truth actually exists. However, there is a strong feeling that there is a much larger animal behind the multiverse invention by Joel Hempkins. In particular, he's still considering this individual verses in the multiverse as set theoretically based. For him, they're just models of some set theoretical universes, which is natural given his genetic code. He came from set theory. Whereas I'm making step to Stanislav, who said that why on earth you bind yourself? Because it's just about theories. It's a hierarchy of theories, a theory, meta-theory, meta-meta-theory, and there is nothing which says that this meta-theory and the theory should be of a set theoretical nature. I agree with that. Now, Grams, I feel that you're making one more step to extending the general approach, the general point of view of researchers in this area, and this is a pluriverse. It looks indeed more general than the multiverses of Joel Hempkins. However, I also have the feeling that the underlying idea, underlying structure is still larger. Because what you're saying, okay, let's use logics, the variety of logics, including non-classical logics, including as general as LP, to build more and more universes. I agree, it works. But we should not limit ourselves to this particular thing. It's a big step forward, but it's like this Indian tale about an elephant and blind guys who are watching. So It's just you observing, you're hugging a big leg of the elephant, yes. But the whole animal is much, much larger than that.
Incidentally, Sergey, you know that comes from the Jain tradition.
Yeah, very good.
They use that to illustrate the perspectival nature of reality.
Absolutely, absolutely, yes. Just but as far as mathematics or some trying to make the whole idea explicit is concerned, we shouldn't stop. We shouldn't stop on the multiverse idea. We shouldn't stop on the pluriverse idea. It's general. It's a healthy general, but it's not. It doesn't project the feeling that it's the absolute. We capture the whole thing yet. Yeah. Now about Stanislav, I also think that Stanislav's idea, so just why don't we limit ourselves to set theoretical? I'm projecting a little bit further. It's all about theories. It's all about theories. By why we're talking about any specific models, any specific set theoretical models, or any specific non-classical logics. Well, this is a very good generality. However, we cannot deny the significance of semantics in mathematics and in logic. So we have to do both. And though your point of view is safe, Stanislav, it is not productive enough, because we have to face the music and to do what the brave people like Joel and Graham are doing. We try to build something, being completely aware that what we're doing the partial of progress, without pretending that it's the whole progress, of course. But so this is my so there's no question actually touched. I'm just sharing my observations and hoping that they'll be useful.
Yeah, look, I don't really see anything to disagree with in what you say, Sergey. I mean, I have a question. I mean, you say we should be going further. No, I don't have a problem with that. I'm just curious to know what kind of further you have in mind.
I would, this is there is a good the comparison, mathematical comparison. It's called coordinate-free geometry. In neither multiverse nor pluriverse is coordinate-free. In Joel's case, it's pinned on set theoretical language. In your case, it's pinned on a much larger variety of things, which is non-classical, the variety of non-classical logics, but still it's pinned on something. Can we make one more abstraction, so truly coordinate-free description of what's going on there in general set theoretical terms, without, or maybe the next step will be the general logical entailment or some kind of logical consequence relation of general kind, not necessarily specifically the one linked to several, the multivariate logic or something of that kind. Yeah. That's the thing.
Okay, look, that would certainly be very interesting. I certainly don't deny that such might be possible. It's hard to see what it might be like. Think of a comparison. I mean, if you take set theoretic reductionism of the kind of 1950s kind,
yes,
then ZFC is the mathematical theory. You can reduce everything to that, okay? What you're sort of gesturing at, as I understand it, is a similar project now, 70 years later, given the fact that we know so much more about mathematics. We still want a kind of mathematics which grounds everything in some sense. That would be fabulous if we could have it. I have absolutely no idea what such would be like.
Yes. This is my way to agree. Yes.
May I also add something to what Sergey said, because obviously this is also the point that was rather clear from your talk, that somehow this whole concept of multiverse was its origin was model theoretic and set theoretic, and certain things you are saying were just a way of doing in a different way that people working in proof theory would formulate differently. In particular, one particular notable case was the use of the word meta theory, where you started to discuss that. So theory versus meta theory distinction. It's of course very, very, very important that really seriously starts there. But in this multiverse picture, under meta theories, you, at least what I heard, that you referred to particular models as meta theories. So you said that one universe can have different properties from the point of view of, let's say, expanding another universe. So if you use that multiverse, that universe as a meta theory, then you see different things. Okay, so in logical practice, in proof theoretic practice, our meta theories usually are not complete, so to say. There's something like Z of C, PA, primitive recursive, things like that. So they would correspond to families of these universes in whatever sense. So that's one point where it's. So I think obviously the balanced picture of this multiverse, so to say, theory should have indeed a nice duality between proof theoretic and model theoretic concepts. So you have families of models, you have a collection of principles, and so on. So that's what I would like here to see in this the development of this.
I'm happy with this. I'm happy with this idea, Lev.
Also, I would like to point out the following, that very early on, Kreisel wrote, and many times, something like the following idea, that let's say that the main philosophical concept, maybe not the main, but one of the, let's say, important philosophical consequences of Gödel's incompleteness theorems is that there is no preferred, let's say, logical theory. Because every theory is incomplete, every reasonable theory is incomplete, therefore there is no, we don't know where to end our process of expansion, etc. So there is no preferred logical theory. And in a sense, this particular observation tells you that one cannot do without considering multiverses, in a sense. So, or multiple universes.
That's interesting. On your first point, I'm happy with that. Even when we're doing ZFC in the old-fashioned sense, when you establish things in ZFC, you're establishing things which hold a whole bunch of models. Okay, and exactly the same is going to be true once you move to some kind of proof theoretic meta theory or whatever else your meta theory is. You're going to be establishing things about a bunch of structures. No, that's fine. The second point is about arithmetic. It's kind of interesting because the distinction between categorical theories that are meant to be categorical and theories which are not meant to be is, of course, a familiar one. So no one thinks that ring theory or group theory or whatever is meant to be categorical. But there are a few theories in the mathematicians deal with that they think that they're meant to be categorical, or at least that there's an intended interpretation.
Yeah.
And the universe view of sets takes set theory to be just such a theory. And so that goes with the pluriverse view. Now, that doesn't leave many theories which are meant to have an intended interpretation, but arithmetic is the last one standing, as it were. Now, nothing that I've said attacks the view that there is an intended interpretation of arithmetic, but I've noticed that Joel does take this view, because I was reading a paper of his the other day where he points out that if you take any member of the pluriverse, you can find another member of the pluriverse in which is embedded, in which the first universe is non-standard. Okay, so every set of natural numbers is non-standard from a different member of the pluriverse. So, you know, if you really dig your heels in there, you're going to say the thought that there's going to be an intended interpretation of number theory of arithmetic is going to go out the window as well. Now, that's a pretty bold move. I don't know what I think about that yet, but it's bold.
I would also say that towards this conclusion, there is also a bunch of results saying that if you, there is no fixed boundary between arithmetical, let's say, statements and set theoretic statements, in the sense that you know that there are some independent principles from piano arithmetic or even larger arithmetical systems if you assume something in set theory, so in the standard Friedman and so on.
That's certainly true. But most people would say that, of course.
I would like to say, but this, that's of course a very common view that natural numbers is fixed.
Yes.
Whereas the sets are not fixed. This, okay.
Yeah.
Essentially amounts to omega model.
Yes.
Or omega, multiverse point of view.
Yeah. I mean, the view that there's an intended interpretation of the natural of piano arithmetic, first order piano arithmetic, for example, is, I think, something that most philosophers of mathematics would still subscribe to. It's a view that I haven't shaken myself free from yet, but it's kind of tempting.
Well, I think that the view is not that there is no standard model or something like that. The problem is with the notion of truth in a model. So you may always find like two universes which have the same set of natural numbers, but which disagree about certain arithmetical sentences, whether they're true or not. Because the notion of truth in a model is set theoretic. And that's one of the papers by Joel Hempkins is about. So that's roughly the claim. And I think that this is a very natural claim because once you consider Prenix normal forms and this, Skolem semantics, you can see that the semantics is very much set theoretic, and it always depends on how many sets you have there. Whether these sentences will be true or not. Well, except for pi 1 sentence, for instance. Well, these are absolute usually. But yeah.
Yeah, no, that's clearly right. I mean, if you want to go non-standard as far as arithmetic goes, you've got a choice. And either you can figure around with the domain, or you can figure around with the interpretation of the function symbols. And both of those is going to, if you go away from the sort of what's normally thought of as the intended interpretation, that's going to give you an unintended model. And you can do it both those ways.
Do we have any more questions, comments?
Anyway, it was very interesting. Thank you very much for your talk.
I think Hitoshi had a question.
Mm-hmm.
I have just a very small clarificatory question. So about this perspectivalism, I fully understood what you said about this earlier part about Joel Hempkins stuff, but then I was just curious what you meant to say for the cases where you start to play around with this and different logics from classical logic. So would there be one funny V all the way long that's different theories would be somehow perspectivizing or something like that, or would there be many funny V's, maybe having some parameters depending on logic or something? I was just curious about that. Maybe you said something about it, but I didn't get it quite clearly.
No, I didn't say anything, Hitoshi. That's a good question. Look, the assumption I was making was that this Gothic V stays the same.
Yeah.
So what you think its structure is going to be heavily dependent on the set theory of the logic and so on. But now you raise the question, there is another way you might go, which is this. I gave you a quote from Joel earlier on, where he talked about the different models of set theory as different conceptions of set. Now, I don't think that's the right way of looking at it. I think there's only one notion of set there, namely the ZFC notion, which can be realized in different ways, just like different rings realize the notion of a ring. Okay, but once you start to move to these sort of radically different set theories, you know, quantum set theory and intuitionist set theory and so on, then I think that it's much more tempting to say that you're dealing with different notions of set. I mean, it's kind of natural to suppose that the intuitionistic notion of species, for example, is a different notion from ZFC sets. Okay, so let's suppose that you are dealing with different notions of set. Then what you might say is that this Gothic V is itself going to fragment, and there's going to be a different one relative to each conception. I don't know what I think about that, but I don't find it implausible.
I mean, I'm just curious, like if you deviate too much from classical logic and somehow the theory starts to capture something maybe like classically completely empty, like pair-consistent topology, for example, that seems to be something that you can only see through this pair-consistent logics and not necessarily from, let's say, consistent logics in general, maybe. I don't have any strong formal results justifying such claims, of course. But in those cases where the underlying logics are really far apart in some sense, then what you're trying to look at from two camps might not be really existing, whatever this means, for both of them. Only one of them can see it, but not the others. So I was just curious about that kind of issue. Once you start to push the boundary towards different underlying logic for different theories. Yeah,
that's certainly an interesting thought. I don't have any more immediate reactions to this. I think it's worth thinking about some more. I don't see offhand what the significant ramifications of this are going to be. Maybe if I think about it, some will occur to me. Or maybe if you think about it, some will occur to you.
But thank you very much for a great talk. I enjoyed very much.
Thanks.
Thank you very much, Graham.
Well, thanks for inviting me, guys. It's been a pleasure.
Absolutely.